Welcome to the program. Starting marking period 4, we are going to begin marking period 4 with 6.1 nth roots and 6.2 properties of rational exponents. So the first assessment, which will be approximately a week from Monday, will cover 6.1 and 6.2. So nth roots, what are we talking about when we say nth roots? Well, we can have fractions as exponents. So if you see something like this, a to the 1/2, and we square it, well, we know from exponents in previous chapters that's equal to a to the 1/2 times 2 over 1. This is equal to a to the first, which is equal to a. All right. Similarly, a, and we say a, just any number, a to the 1/3. If we were to cube a to the 1/3, that's equal to a to the 1/3, a to the 3/3. I'll skip a step there. A to the 3 over 3, which is a to the first, which is a. Okay? And finally, a to the 1/4. If we were to raise that to the 4th power, that's equal to a to the 4/4, which is equal to a to the first, which is equal to a. Okay? So what do we learn from that? Just that when you have a fraction in the exponent that you could, and it's raised to another power, you multiply those exponents, which we learned that before. Okay, moving on. So, there is an n root of a, and what that means is let a equal a real number, and let n be an integer greater than 1. So to do the nth roots, we have these rules. And the first one we'll do is if n is even. So we have two sets of rules for n is even, n is odd. If n is even, right? All right. So n is even, so we still have the conditions of a. If a is less than 0, then there are no real roots, right? If a is equal to 0, then there is one root, which is the nth root of 0, which is 0, right? And if a is greater than 0, then we have the nth root of a. But we have to consider that there are two real roots, so plus and minus, right? Which is equal to plus or minus a to the 1 over n. All right? So that's if n is even. If n is odd, we have a set of other rules. Okay? And so we say if a is less than 0, then we have one real root. Okay? Which will be the nth root of a, which is a to the 1 over n. Still, I should put up here, this is two roots, real roots. If a is equal to 0, we have one real root, the nth root of a is equal to 0. The nth root of 0 is equal to 0, right? Because a is 0. And then the last condition is a is greater than 0, which is still one real root. So if n is odd, then you're usually just getting one real root, all right? So this is going to be the nth root of a, which is a to the 1 over n. So two quick examples, all right? Example 1. If n is 3 and a equals negative 216, find the nth root. Okay, well, a is sort of, so we continue with negative 216 to the 1/3. Okay, where did that 1/3 come from? That came from n. All right, so a is the base, n is odd, so there's going to be one real root here. This is equal to the third root of negative 216, which is negative 6. Okay? Example 2. If n equals 4 and a equals 81. So we're given these two things, and they want us to find the nth root. So a is the base, 81, right? And n, we go 1 over n, 1 over 4. But we remember now that n is even, so this is going to be plus or minus the 4th root of 81, which is equal to plus or minus 3. Okay? And thank you for watching.